A warm welcome to our webinar. My name is Philipp Schwab and I work as a Technical Marketing Manager at CAD-PLAN. Today, my avatar will guide you through this webinar. It is great to have you with us today. In the next few minutes, we will show you how you can use our new CAD Complete Collection to make your planning and engineering processes in metal construction and facade engineering more efficient. The CAD Complete Collection combines ATHENA Complete and APOLLON Complete into one seamless solution. This allows you to connect structured 2D planning with detailed parametric 3D construction. Especially when working on complex sheet metal facades, it is essential to create planning reliability at an early stage and to prepare construction details in a clear and structured way. In today's webinar, we will show you how to establish the right foundations in the design phase in order to move smoothly from 2D planning to 3D construction without workflow interruptions. This means less rework, less coordination effort, and greater reliability throughout the entire project process. In Part 2, we will show you how manufacturing processes can be accelerated in a targeted and structured way. The focus is on sheet metal engravings, assembly drawings, and the clear visualization of how the entire construction is put together. You will see how individual components can be clearly identified and prepared so that they can be processed quickly and reliably in the subsequent stages. Sheet metal engravings provide a major advantage here, as important information is available directly on the component and can therefore be assigned without ambiguity. Another key aspect is the use of assembly drawings. They make it transparent how the individual components fit together and how the overall construction will be assembled step by step. This not only creates better clarity during the planning phase, but also increases confidence during practical implementation. In Part 3, we will then focus specifically on manufacturing. Here, the emphasis is on how the engineered components can be further processed in a production-oriented way and prepared optimally for fabrication. This includes flat patterns, bills of materials, and the seamless transition into downstream manufacturing processes. You will see how concrete production data is generated from the prepared design and how it can be used directly in the next stages of the workflow. This step is particularly important in real project environments. Only when engineering and manufacturing are closely connected can a truly continuous process be achieved. This helps to reduce errors, accelerate workflows, and significantly improve overall efficiency. Part 3 clearly demonstrates how the CAD Complete Collection not only supports planning and engineering, but also actively integrates manufacturing. The result is a seamless workflow with greater structure, higher reliability, and improved efficiency throughout the entire project lifecycle. The CAD Complete Collection combines powerful 2D and 3D CAD solutions in one highly attractive package. You benefit from an exceptionally cost-effective overall solution that efficiently connects planning, engineering, and manufacturing. One key advantage is the sheet metal interface, which allows sheet metal bent parts to be created and further processed in record time. This not only accelerates the design process, but also significantly shortens the path to production. In addition, important interfaces for EluCAD, ChemQuix, STEP, SAT, and ERP systems are available. This enables data to be transferred securely and seamlessly into downstream processes. With fully parametric design capabilities, you gain maximum flexibility when implementing changes or adjusting technical details. At the same time, the CAD Complete Collection offers BIM compatibility within the Autodesk environment, supporting modern and fully integrated planning workflows. Another decisive benefit is the high quality of the overall solution. And the system also supports education and training, as the CAD Complete Collection is available as an educational license. At this point, we would like to express our sincere thanks to our customer, the engineering office ProPlan GmbH. For this webinar, ProPlan kindly provided us with the project drawings as well as the 3D model. The project itself was planned and engineered using ATHENA Complete and APOLLON Complete. ProPlan stands for Professional Metal Construction Planning, strong technical expertise and reliable partnership. The company is also a competent point of contact for all areas of metal construction. We would like to thank ProPlan for the trusting and successful cooperation. We move straight into the construction phase. Several layers interact with one another. Different materials and construction elements have to be coordinated with absolute precision. These 2D sections provide the foundation for that process. Even from this single section, you can already see how complex the facade structure really is. All of this was created entirely in ATHENA. From this view, we select a specific facade element and continue developing it further. That element is then engineered in APOLLON as a sheet metal facade component. There, it becomes a complete 3D model with a parametric structure. And this exact 2D planning now serves as the starting point for the next step. With the powerful 2D technology in ATHENA, you create a precise planning foundation. You reduce errors at a very early phase of the project. At the same time, you produce drawings with high quality, a clear structure and reliable detail depth. This creates a dependable basis for further engineering and a fast transition from 2D to 3D. And now, we will show you step by step how this workflow comes together. We begin with the ATHENA 2D section. Based on this 2D planning, we now want to draw a windowsill in cross-section. It is exactly in details like these that the importance of careful preparation becomes clear. The cleaner the planning is at this phase, the easier the construction process becomes. With ATHENA, you can create sheet metal cross-sections in a wide variety of construction options. For this, you use the sheet metal cross-section command in ATHENA 2D. This allows even more complex geometries to be created quickly, precisely and reliably. At the same time, you keep full control over the structure and technical design of each detail. With just a few clicks, the required cross-section is complete. You can also apply sheet metal cross-sections directly to the substructure. This creates a solid and dependable foundation for the next phase of 3D construction. It means that the essential elements are already prepared to support a smooth digital workflow. This clearly shows how simple and efficient the preparation of sheet metal parts can be for the later 3D construction in APOLLON. This is exactly the preparatory work that makes the 3D processing smoother. The ATHENA 2D substructure has now been fully prepared. Using ATHENA 2D Plus, you can now place the sheet metal parts directly onto the 2D element with ease. This creates a clear foundation for the next phases of construction, step by step. One important aspect here is the base point. It defines the exact position of the element and ensures that the correct placement within the plane is maintained later on. This keeps the construction cleanly aligned and consistently structured. A major advantage is that the existing 2D detail sections can be reused directly. They are not only valuable for planning, but also serve as the basis for the later 3D processing. This means your familiar 2D construction workflow remains fully intact. At the same time, you create a solid foundation for the next phase of modeling. In the next step, we will take a closer look at the window sill connection. This area has already been prepared using ATHENA 2D+. Additional sheet metal bent parts have also been placed, and we will continue working on them in the next step. This example shows very clearly how precisely prepared 2D information can be used for the following step of construction. In this way, important connection details can be defined early and transferred accurately into the process. The prepared sheet metal cross-sections can be placed quickly and adjusted flexibly. This allows you to define important construction details already during the 2D planning step. The drawing quality is another clear advantage. Detailed sections and views are available early and can be used directly for planning and fabrication. In the next step, you can convert the sheet metal parts created in ATHENA 2D+ directly into an ATHENA model. At the push of a button, a complete 3D model of the element is generated immediately. This allows you to move from 2D preparation to 3D visualization without any detours. And this is exactly where valuable time is saved in the construction process, because the model does not need to be recreated from scratch. After that, we transfer this data directly into APOLLON. There, the complex sheet metal parts are processed further in the next construction step. A major advantage is that all 2D information remains fully preserved throughout the process. You continue working with your ATHENA planning, the existing 2D sections and the ATHENA 2D+ views. This creates a seamless workflow from the initial preparation all the way to the detailed 3D construction. And with that, we move to the next step. In the next step, we can see that the sheet metal parts created in ATHENA have already been assigned article numbers. This means that the information can be reused directly in the following phases of the process. Using an XML transfer, the data can be passed smoothly to your ERP system. This allows you to integrate the components directly into your existing company workflows. One important advantage here is the support this provides for cost calculation. Based on the available data, you can determine quantities at an early stage and plan material requirements much more accurately. So even at this stage, you can already see how many components will be needed and which materials will be used. This creates a solid foundation for the economic planning of your project. At the end, you can see the result we want to achieve: a fully engineered sheet metal element. With precise bends, the corresponding sheet metal blanks, hook-on punching details, and all required additional components. This is exactly the element that we will continue working on in the next step and engineer in greater detail. In this way, the prepared planning is transformed step by step into a fully defined sheet metal element. We are now using the sheet metal interface available in the CAD Complete Collection. Through this interface, we transfer the sheet metal element directly into APOLLON. In the next step, we want to continue working on this element in APOLLON. This allows us to move straight from the prepared construction into the next stage of processing without any detours. Of course, all information is retained. The positions from the ATHENA project browser have also been transferred into APOLLON. they are visible there. This allows you to clearly identify which position and which component from ATHENA is being processed further in APOLLON. Now we can see the completed sheet metal facade element in its prepared form. Let us now move directly to the windowsill and continue working on it within the project. Our goal at this stage is to refine the windowsill of the element. To begin, we quickly and precisely add bends at both ends. This is where one of the major advantages of the sheet metal interface becomes clear. When working with complex sheet metal components, it saves valuable time. The prepared data is already available and can be processed further immediately without rebuilding the part. You can see very clearly how easily and precisely we can work in the sheet metal design process. Individual editing steps can be carried out directly on the element and adapted to the structural requirements. In the next step, we create the notches. This ensures that the vertical profiles connect cleanly to the windowsill and that the cut parts fit exactly. These editing steps can also be performed directly in the model. This means that you always retain full control over the geometry and every machining step of the component. You can also see how precisely the bends can be coordinated. In facade elements, the exact coordination of the individual sheet metal bends is especially important. That is why APOLLON provides a high level of reliability in sheet metal construction and ensures a clean, consistent development of the entire element. In this way, a precisely engineered sheet metal facade element is created step by step and can then be processed further with confidence. Now we move on to the drill holes. We will now look at how slot holes can be placed in the windowsill in APOLLON easily and intuitively. This is exactly where the efficiency of working directly in the model becomes clear. The slot holes can be positioned precisely and adapted cleanly to the structural requirements. A key advantage here is parametrics. In APOLLON, parametrics play a central role in component processing. This means that changes can be implemented safely, quickly, and in a controlled way at any time. If dimensions, distances, or positions change, you simply adjust the relevant values through the parametric settings. So processing steps do not have to be rebuilt from scratch, but can be refined further in a targeted way. This saves valuable time and increases planning reliability. You can clearly see how easily, precisely, and detailed processing steps can be carried out in APOLLON, particularly for recurring components or parts that require frequent adjustments. This way of working is especially efficient. This creates a flexible foundation for the further development of the sheet metal element and for the fabrication process. We now move on to the processing of the cleat punchings in the sheet metal facade element. For this, we take a sheet metal bent part that we previously transferred from ATHENA into APOLLON. Using the positioning data that was already transferred from ATHENA, we can identify this component directly in the APOLLON model browser. This provides additional security within the project. You can immediately see which component you are editing and exactly where it is placed within the element. In the next step, we carry out the cleat punchings directly in APOLLON. Here again, parametrics play a central role. Using parametrics, this processing can be defined quickly, easily, and reliably. You specify the required dimensions and then apply the desired processing directly to the component. This allows the cleat punchings to be adapted precisely to the structural requirements. If dimensions or positions change, they can be adjusted at any time through the parametric settings, without having to rebuild the component. This is a major advantage, especially for complex sheet metal facade elements. It saves valuable time and at the same time increases accuracy in the construction process. Once the processing has been applied, APOLLON handles the next steps automatically. The sheet metal component is then processed completely, and each individual processing step is integrated safely into the existing construction. In this way, the work continues bend by bend. Cleanly, transparently, and with a high level of precision. You can see very clearly how efficiently even demanding cleat punchings can be carried out directly in the model. The combination of transferred positioning, clear identification in the model browser, and parametric editing creates a consistent and reliable workflow. In this way, a fully processed sheet metal component is created step by step. All relevant processing steps are applied precisely and integrated cleanly into the facade element. That is exactly what makes processing in APOLLON especially efficient. You work in a structured, reliable and flexible way, and even complex sheet metal components can be brought to a fully processed result much faster. Let us move to the next step, how the process continues. We can now see the finished sheet metal component. The cleat punchings has already been fully completed. At this point, you can clearly see that the processing fits cleanly with the other components. This means that the construction is correctly built at this stage. However, a small error has still occurred. That is exactly what we will look at now. Because situations like this cannot always be avoided in day-to-day project work. What matters is how quickly and reliably such deviations can be corrected. And this is where another major advantage of parametrics in APOLLON becomes clear. Using parametric editing, we can make the required adjustment quickly and easily. This allows the error to be corrected directly in the model, without rebuilding the component. The result is a fully completed sheet metal facade element with all parts and all processing steps in place. The entire workflow from 2D planning to the finished 3D element has now been completed. Thank you very much for your attention, and now let us return to the presentation. Let us summarize the key points once again. You have seen how a targeted transition from 2D planning to 3D construction can help you save valuable time during project preparation. Especially in sheet metal design, this structured workflow enables a significantly more efficient way of working. At the same time, it has become clear how even complex sheet metal components can be engineered in a reliable and transparent way. By consistently using existing planning data, potential errors can be identified at an early stage and reduced in a targeted manner. Thank you very much for your attention and for your interest in our webinar. If you have any questions, please feel free to contact me directly, Philipp Schwab. Simply send us an email at webinar@CAD-PLAN.com. You are also welcome to scan the QR code shown on screen and follow our YouTube channel to stay updated and not miss any future content. We would also be delighted if you follow us on LinkedIn. Thank you very much, and we wish you continued success with your projects. See you next time.